Oh man, we're live. We had a cool video that's doing a thing. Is it
Doing
going
it
to end on
live.
its own? I don't know. Let's see. We'll just, okay, we can go away here. Oh, there it is.
There we are.
There we are. Two people having a
On a
nice
screen.
time. Just two people just talking about technology, maybe, or ourselves, or I don't know, anything. Let's see what we have going on here. Looks like we have a handful of questions already. That's pretty exciting. So yeah, let's dig right in. Hopefully my sound is okay. Hello, Sarma. Good to see you, buddy. Hey, Sarma, are you watching on? Are you on LinkedIn? No, you're on YouTube. I see. Good. Okay, so that means that YouTube comments are coming through. I've seen some times in the past where comments don't come through on LinkedIn, so we're gonna have to just make sure that we don't miss those. Do you have those, Jordan?
Yes, I do.
All right, you're in charge of comments on LinkedIn.
Yep.
So let's see now. What day is it? Friday, February 28th. It's a nice little Friday morning, 11 a.m. here. I'm in Southern California.
11 a.m. for me too, but just in Nevada. Beautiful sunny day.
So I haven't had a live stream in a while, and I got to be honest. I've been saying that I want to start doing it again. Things kind of got insane for the last 6 months. Really, I've just been so swamped with stuff that I really haven't had a spare minute to do this. But I miss doing it. I actually really like doing this, and I have a good time, and I like talking to people and like answering questions. So we're back. We're doing it again. So before we get going, before we just dig into some questions, let's share a little bit, just in case folks don't know everything about ourselves. Jordan, you want to do a little intro for whoever's watching?
Yeah, absolutely. So my name is Jordan West. I've been working on the Cassandra project for almost 10 years now. I'm a committer and PMC member. I've operated Cassandra at some of the larger deployments of Cassandra at both Apple and Netflix, as well as I'm a regular contributor. And I just love, talking about Cassandra, operating Cassandra, making Cassandra better, and looking forward to answering questions today. John, I'll turn it over to you.
All right. I'm John. I worked with Cassandra for a long time. I've got 20 years of software engineering kind of background professionally. But the last 12, I started working with. 12 years ago, I started working with Cassandra at a startup, and basically it kind of took over my professional life. And it's just been nonstop working at. I mentioned startup and then DataStax, the last pickle, where I got to work on a ton of really cool open source software. Apple, Netflix, you and I had to fix a few things over at Netflix together. Pretty good times. And now for the last 2 years, I've been doing my own thing. That's what Rusty Razorblade Consulting is. Did I spell that right? Looks like I did. I have misspelled my own company name in slides, and slightly embarrassing. Yeah. So I like to share a lot of what I've picked up over the years. I think that's why I actually really enjoy the role of consulting. I like helping people, and it was really a foundational kind of reason why I wanted to get into training. So when I first started out, I was like, oh, I'm gonna just go back to consulting, because that's what I did at TLP. But Jordan, you and I at the Cassandra Summit a year and change ago, we partnered up with the Axon Ops folks, and we did kind of a free show up, and you can just ask stuff, and we'll try and help you out. And it was actually an amazing session. There was like, a bunch of tables and people were rotating around. We were just kind of answering stuff, whiteboarding. And a little bit before that, I think leading up to it, we were like, let's do a training. Like, let's make this thing a reality.
I think a lot of folks are doing really awesome stuff with Cassandra, and there's sort of like this learning progression you go through. And I think we recognize, like, hey, let's help people skip some of that progression and jump right to, some of the experiences we've had and share that. And that, like you said, that was like the seed that sort of planted this training we've been doing. And that's been a whole new, I didn't realize how much I was going to enjoy just watching other people be successful with Cassandra. We've worked now with a few companies and a few public trainings, and getting to see the impact of those has been, really motivating to do more of these.
Yeah. Oh, it was so much fun, and we're getting ready to re-record all our content, update the training for Cassandra 5. So if folks are interested in that, we'll talk a little bit more about that later. But registrations are open right now. It's going to start at the end of April. I think we have 6 or 7 slots left, and these are small groups. We're not trying to like crowd as many people in. Like, the goal is to really deliver something awesome for people.
Yeah, I think the 2 goals are small group size, small class size, and hands-on nature, right? Yeah. Like, this isn't a training where we just talk at you. Actually, all the talking is in the videos that we share ahead of time. And the sessions that we do, they're now, we're doing 6-week, 2.5-hour sessions, I believe. They're super hands-on. So Q&A at the beginning, either about your own problems or about the videos that we share. And then the rest is like real lab scenarios. So John had built a tool called TLP cluster that we now call Easy Cass Lab. And then we have another benchmarking tool that was TLP Stress and is now Easy Cash Stress. And we use those to set up real environments in the training that let you have like sort of like a safe space to break a cluster and figure out how to fix it. And by the end, John and I are basically hands off, letting the group tackle the problems together and see how many problems they can solve.
Yeah. Hey, Jordan, can you turn the mic up a little bit? I think you just may have nudged it a little bit too far.
Yeah. It was. I thought it was clipping a little.
Yeah. So I'm glad you brought that up, the TLP cluster stuff. When I was working at the Last Pickle, we would get all these consulting questions, right? Like, I spent 3 or 4 years there. People come in, they say, "Hey, I have this situation. What do we do?" Right? Especially if it was a bug. You really need to reproduce it. So built out the tooling, built out the stress tooling. So now it's like I have a custom tool for building Cassandra Lab environments and a tool for running load tests. Super powerful. Like, I've used it literally to solve hundreds of problems that otherwise you're just reading through code and speculating. The real power is with the hands-on. Let's stop talking about the training just for a minute. Let's answer a question.
Well, I was going to say it's a great transition because we talk about the tools and talking about qualifying patches. And we've got some questions about Cassandra density, which we'll come to. Why don't we, John? Why don't you pick the first question though?
All right. So the first question that came in. So I'm just putting these in the order that we received them. So the first question that I got was, are there any parts of the Cassandra API that you think hold the project back? Seems like the API has been pretty stable. Major version releases are more based on new exciting features and breakages. So curious where you think that's not the case. It's definitely an interesting question. I think there's a few aspects to the API, right? Like, because there's a few places where you interact with it. You interact with it as a developer, with CQL. I think, so I'm a little bit biased because when I first got started, CQL had been recently introduced. I don't know what year you started working with Cassandra. I don't know if you were a Thrift first.
I was. Yeah, I was. And actually, I worked with a few folks who were staunchly like, we're only doing Thrift.
Yep. Yeah. And that was like, when Thrift appeared, I was like, oh, sorry, when CQL appeared, was literally like, I think it was Cassandra 1.1 when I first got in, because you actually, to use Cassandra 3, I'm pretty sure you had to like pass a flag like CQLSH-3 or something like that to use it. And I was like, okay, like, where do I want to go? Where's the future here? What's like the right strategy? And it seemed to me like CQL was was really cool. Like, I like schema. I like strongly typed schema. I like putting that data in there. It helps users and tools, right? Like, and so there's a lot of Mongo stuff happening. There was like, at the time, like Neo4j was kind of picking up steam, where I was like evaluating like all this stuff. And you know, I have a relational background. I know that you spent a lot more time in with React. So I know that your like distributed systems background is kind of a little bit different than mine. I don't know if you did relational started out. Did you?
Not like working on relational internals, but yeah, when I started, I mean, I was mostly building apps on relational, and then my career kind of like started growing right as NoSQL became a thing. So yeah, a lot of my focus was in the NoSQL world, operating Mongo and Redis at scale before, and then working on React, and then switching to Cassandra. So a lot of my career has been spent in like eventual consistency land.
Yeah, which is weird. It's so weird. That's probably one of the areas of the API or the area that where Cassandra behaves that can be difficult. Like I've definitely worked in some eventual consistency problems with clock issues and all sorts of things. That's probably one of the areas I'd say as a developer that can be the hardest to understand. Like, especially if you're coming from a relational background, you're probably used to a relational mindset. And then you're like, hey, this behaves differently. Like, why do I need to care about consistency levels? What does that even mean? Multiple data centers, the way things fail over. There's lots of really good reasons, like computer sciencey reasons for it all, but it can be pretty overwhelming if you're brand new to it. But there's more to it, right? There's not just that. There's there's JMX, which I think for a lot of people, there's a lot of deep dislike. I know that if you don't have a Java background, it's like, why do I need to care about JMX? Like,
yeah, and it's so verbose to get stuff done, like without having like a client.
Agonizing.
Like if you use JConsole and you got to know where like, the proper formatting, the semicolons and the dollar signs to get to the various functions, if you're using like the command line version and things like that. And I guess my answer to this question is a bit tangential to JMX, but I think like one of the interfaces holding Cassandra back is its config. And I mean that as a whole. So the config and the YAML, the fact that we have both global config and local node config in a single config file can lead to like certain unexpected behaviors. So like, for example, what does it mean if I set the, initial tokens to a specific token on 5 nodes and I set it to like a number on another 5 nodes, right? Yep. And then the other aspect of config to me is that the vast majority of it is not what we call hot. And that like a large portion of settings that shouldn't require a restart do. And when you have like a real cluster, and we hinted a little bit about density, and there's a question we'll come to a little bit later about density. When you have a really dense node, that startup time is actually expensive, right? And so you're there like, oh, I want to change a setting, and I got to wait like 20 minutes, let alone now you have a 300 node cluster and you have to figure out like rolling restart across the fleet and things like that. So I think having a more like a way for the Cassandra developers to do hot by default, whereas right now it's something that we have to do manually, would make that a more seamless experience for our customers, for the users of Cassandra.
Yeah, and I think on that note, there was a discussion on the dev mailing list a few weeks ago about, maybe months ago at this point, about like putting the config available in CQL. I think it would be very, very, very cool if most of the config actually lived at the like inside the cluster itself and wasn't based on like we currently ship I haven't looked at it in a little while, but it's at least 1,000 lines long Here, I'm actually I'm gonna check on this now.
Now you're curious.
Yeah, now I'm like, so if I look at the Cassandra YAML right now, it's 2,200 lines long, which is like.
And that's without like the config that the developers have decided to hide from the YAML, and there's a lot. So I think that's to me one of the biggest areas. And that's not to say, by the way, we've done a lot of improvements in config. Kudos to some of the folks in the community. For example, there's the hierarchical YAML now, and if not, you had these like crazy long config keys that were a big pain. Some of those things, and then the other part I'd say is. I mean, this is somewhat natural, but there's also this config split across like the YAML versus the JVM flags. And some of the JVM flags have to be set, right? Like the JVM has to be started up in order to read the YAML. So you can't set the heap from the YAML, for example. Right. But we do have some features like skipping the schema check on startup that is only settable via JVM flags if you know they exist.
Replace address first boot, I believe, is a
yes, exactly,
exactly. I think so. From like a interface perspective, there's definitely a lot of places where we could definitely improve, and I think that kind of speaks to the. I mean, it's a complex project, right? It's
a complex project that's grown organically. It's an open source project with a lot of contributors. So, it's not to say that there aren't valid reasons that we got here, but if you're asking what areas I think could be improved, which the question was, we got a few more questions coming in. Anything else you want to add here? Or let's tackle some of the.
Let's move on. So let's keep going with the ones that were asked beforehand. I want to let's just go with the next one we have. If I may. I have one question. What is the best, fastest way to change huge Cassandra table primary key? That's an easy one. You can't.
You would have to rewrite the data, and we can talk about that. But the Cassandra data is, distributed by primary key. So you can't like go rewrite those keys. If you overwrite a key, you're really creating a new key. And so that leaves you with a couple options. The option that I would prefer, if it works for your use case, is to pull all that data offline into some kind of data warehouse. There are open source tools, depending on what version of Cassandra you're using, like the Spark bulk reader and writer that have been recently open sourced. There's also the Hadoop connector. It has few more performance issues, and you are saying it's a relatively large table. I don't know if you want to quantify large in terms of like terabytes, petabytes, gigabytes, but it depends on the data size. But if you pull that data offline and then you rewrite it offline and then import it back online, so you could do this by pulling the data out with the Spark bulk reader, transforming the data with your own Spark job, and then writing it back with the Spark bulk writer. This has the advantage of doing it all without touching the front door Cassandra cluster. We're loading the SS tables in after they've been generated using the bulk writer, and we're pulling the data directly out of the SS tables using the bulk reader. Yeah. The downside is if you need to do something live, and then the alternative would be to use the front door, so to like read the key, rewrite the key, delete the old key, and kind of go progressively through this. That's going to put a lot of load on the front door of your cluster, and you may find you need to scale it up as a result, or you have to build some kind of like throttling, and then you're going to have to do some math on like how many keys can we do per second and how long is the migration going to take.
Yeah, and realistically, one of the problems there is like you brought up how much data are we dealing with. Super critical to know that, because let's suppose you have a 300 node cluster and you're running at 60% disk space. You brought up, do I have enough headroom, do I throttle? But you also have to factor in that now we're probably going to be doubling the size of our data footprint as well.
Yeah.
So one thing to consider is if you're going to do a migration like that, it's really nice to be able to have the ability to set up a new cluster, because when you're rewriting, let's say half a petabyte of data, you really want to put that pressure on an environment that's not your production environment.
Yeah.
Like it's a really good idea if you can set up even if you can set up a second DC to do the read from. Now you're isolating that workload. That's easy to do. There's actually a question in here about how do I set up a new DC, so this kind of gives us a nice.
It's a good transition, but yeah. And especially if you're going to do scans to figure out which keys you have to update, right? Because if you need to figure out the whole set, that scan is going to be really expensive.
It'll be brutal. And one thing I do want to point out, though, that's pretty fun, that we can pat ourselves in the back. Cassandra 15452 is for those of you that are not following the individual tickets that are being worked on in Cassandra. This is a ticket that Jordan and I have been working on for a while now, and just kind of on and off over the last year. But what it does fundamentally is massively improve the performance of a whole bunch of bulk operations, compaction, and then that kind of includes repair, but also range reads. So if you are going to do a bunch of reads on a lot of data, we're actually going to get, hopefully, I think you're going to try and get this merged in next week, right?
I'm literally actually planning to look on the follow-ups this weekend,
Awesome.
later today.
Perfect. So we'll get that, once that's merged in, if you look at the notes, I did some range read tests, and it improved range read performance by 3x, which is just crazy. Like, and this was on EBS too, where you're constrained on the number of IOPS.
Yeah.
Anyway, yeah, I just had to promote that for a second, because it's going to be amazing. Massive cost reduction. We're working on this with a team that has 600 nodes. They want to run fewer nodes, save a little bit of money, and this is actually going to help them do that.
Yeah, and thanks to a few community folks who have run it in their own environments, we've seen confirmation of those numbers against real clusters too. So John and I are really excited about this patch.
Yeah, I'm pumped out of my mind for this. To me, it's a game changer. Anything that cuts your cost in half is just nuts to me.
Yeah. Very excited. Yeah, so since you brought up the second data center, should we transition to Prabhu's question about adding a data center? Because it kind of goes to also Jiraj's question about how would you solve this problem? Because one way is to add the data center.
Let's get into it. Setting up a second data center is actually, it sounds like it's kind of a scary thing if you've never done it, but it's actually one of the things that Cassandra has been doing for a long time, and it's done really well. Like, when you do it, it's like, oh, it wasn't hard at all.
Yeah.
Assuming that the node, Thomas, don't worry, man. Yeah, hold my feet. We'll talk about 24 bytes per node. Not a problem. I'm fully prepared. But for now, the second DC stuff. Once you've added the nodes into the cluster, and that means like they're talking to each other, it's actually pretty simple. So you bring your nodes in the cluster, you point to the other one, you have the seeds, the seeds from the other data center in there. You join the cluster, assuming all your network stuff is configured correctly, and your two DCs are talking to each other. It's literally just a matter of updating your replication factor to point to the new DC as well, and then running a node tool rebuild on each of the nodes in the new DC. It helps a ton if you're using a low token count. So I recommend people to use no more than 4 tokens per node, even though it ships with 16. There was kind of a 16 is sort of the
maximum.
Yeah, I wouldn't use 16. I think it's you actually hit a number of issues the more tokens that you use. 4 gives you all the benefits of using tokens without kind of the headache. And I can go into that later if anybody cares. I'll go into it. Just say something in the chat, and then I'll we can talk about the problem. Once you've run rebuild, all that data is streamed over, and then you're good.
It's straightforward. Doing it at scale over a few hundred or thousand clusters after recently adding another data center. Can you hit something at the larger data sets? Yes, they tend to be not with like the rebuild process itself, but with streaming and over streaming or network issues underneath. But for the vast majority, it's very smooth and again, as John said, like a very well supported addition. It is easier when you keep the same number of nodes, which the question is asking, in each data center. It makes that rebuild process a bit simpler. Although, like John said, if you're using vNodes, that's a little bit different. I come from a background where we don't use we use basically one token or not vNodes, so things are a little bit different for me. But for the vast majority of clusters, who are using vNodes, you have a little bit more flexibility there.
Yeah, and pretty much, it's kind of funny. Like the folks that are using single token are either tend to be people that have been operating Cassandra for a really long time, since before vNodes were a thing, and those environments tend to also be built by people that are contributors to the project in a significant way. You don't really see a lot of that tooling being developed by people that are brand new. It's kind of like most people are going to put defaults in production, and then you learn from there. That our defaults aren't that great in a lot of cases, but they're getting better. So anyway, hopefully that answers that. Let's move on. So we have our DC question. Question from Sarma. What's up, buddy? What do you like about Java 17 for Cassandra 5? That's a great question. So I think that the number one thing that I'm interested in is evaluating Shenandoah. And I actually have that. I'm glad this question came up, because I'm about to evaluate whether or not Shenandoah has any issues for the client that I previously mentioned that is massively pushing data density. Part of the reason why Jordan, you and I have been working on this patch is because of this problem where folks want to run a lot of data per node. Like if you look back in time, there was advice like run 500 gigs of data per node, run 1 terabyte. It was just not a lot. And I think that the project has done a great job of identifying performance problems. And one of the biggest ones, one of the biggest holdups with data density is compaction, because you need to be able to keep up. Again, and this is where our patch is going to come in. So 5.0 is actually going to be much easier to run denser nodes. Anyway, the part of that though is how long, what do our JVM pauses look like? And I'm about to start the evaluation on, okay, can we run Shenandoah with much denser nodes with some of the new features like tri-mem tables? Already running that in production, actually. It's phenomenal. I love tri-mem tables. And UCS, they're both just amazing. And they can actually really help push on the data density side of things. I do have a plan, not a little segue here, to talk about that. So I gave a talk at the Cassandra conference in Denver about the path to 20 terabytes per node and all the things that have to happen along the way. So there is I do plan on getting deeper into this. I will do this kind of follow-up thing at some point. And I also have blog posts that I'm working on the topic. One's going to be coming out next week is the goal. And I'm going to be talking about streaming and the impact of streaming on data density. So anyway, there's a lot that goes into it. It's like there's not one silver bullet. There's a handful of things that we got to address. So anyway, Java 17 for me, it's GC. I don't know if you have
I mean, personally for me, I think Java 17 is an incremental step forward. I'm really more excited for 21 and when the project fully supports 21 and generational ZGC, just because I've seen some early numbers on pause times, both inside and outside of Cassandra, that are massively exciting. Yeah. And I think ZGC will be I think Shenandoah is from the numbers I've seen. I'm interested to see your numbers, but my inclination is it's a step forward for Cassandra, whereas ZGC is a leap forward for Cassandra performance, cost, and density.
Yeah, I think it's a great analysis, and I feel exactly the same way. I mean, to me, generational ZGC is kind of like the I think like my understanding is that it uses a lot of the same ideas that were present in what was it, Zool or no?
Yeah. Well, Zool or and Guild, the company that Guild drove.
Yeah. Guild 10A.
Yeah.
With the alternative JVM that basically has almost no pauses.
Azul is the free one, and then Azul is the paid one. Yeah, which I had the pleasure of operating Azul, maybe I don't know, 7 or 8 years ago now, and it was just so far ahead of the rest of the world that. It was super compelling. But at the time when you ran Azul, you had to literally give, like, you had to have these beefy boxes to run Cassandra on them, and you would give like half of the system memory to the JVM, and not like in the normal way, like where you specify a heap. This was separate. You actually like literally gave it the raw system memory just to Azul, So I'm really excited to see that, like, we have in open source now a path forward for the JVM that's well performing like that. And so coming back to the question, I'm really excited for 21. I think 17 will be a nice step forward, but 21 is really where my focus is, and the community is working on 21 right now.
Yep. Yeah. Agreed. Next question. Let's see. Is there one metric that can tell me how busy a cluster is? Yeah, there's
not one.
Yeah, there's not one number. Am I busy? But there is a Thomas. I think Thomas actually.
Like the read operation latency, write operation latency, is what Thomas called out.
Yeah, I'm not actually seeing his comments now. I think this is a.
I think it's like a LinkedIn. Some of them have been coming through. I've had to double check on.
Yeah, LinkedIn's buggy.
Because like they show up on StreamYard. But Thomas had responded, read and write operation latency. I think that's how you can tell how well the cluster is handling how busy it is. In terms of how busy it is, I would look at a few metrics. Obviously, read and write throughput. You also, when you look at reads, you have to look at point read throughput, so normal reads, and scan throughput, because those are different. And then on the right side, you have to look at writes versus LWT writes, because those are going to be different as well. So that's how I'd look at like the volume of busyness on the front door. You also want to be looking at like what I'd call like the back of house busyness, and that to me is how often are you flushing mem tables? So how quickly are you turning the in-memory data into on-disk data? And how often are you like how busy is compaction, and how far behind you are on compaction? And I think that kind of gives you a mostly holistic picture of what this cluster is doing. There's some other background work like index resummarization and repair, but those happen less frequently. If you're looking for a baseline of how busy you are, sort of those, I guess it's, what is it, 6 metrics. There's 2 for reads, 2 for writes, and then the compaction and mem table flush that I'd be looking at. And then there's obviously, and I think it's something John's very passionate about, but it's not just how busy Cassandra is, but it's how busy the system is. And so you can start looking how busy your network and your disks and such are. Yeah,
there's because busy is, it's like, there can be a lot of different meanings to it. And if the question is like how busy is my system, isn't really on its own that useful, right?
How utilized is my system?
What percentage, like, do I have more resources available? There's the performance side of it where it's like, my system might be busy, but if you're falling within your latency objectives, then you're okay. But when it comes to kind of doing a performance analysis, there's a lot more that goes into it than that. I think this is one of the things that I'm really happy about that we have in training. It's really kind of taking the these skills of like being able to do an in-depth analysis of a system and understand where your bottlenecks are coming from. that is a lot more involved than just, there's no one number right now. Like there's no.
And Piotr just kind of asked a question about this, right? Which is like IO, like what about IOQ depth? And so IOQ depth on the disks is one, but actually there are also Q depths in Cassandra that you can monitor. And we have a whole week dedicated to these thread pools and their queues as part of the training. Quickly on the surface, you've got the native transport queue, you've got the read and write queues, and then you have the internode messaging queues.
Yep. Yeah, it's it can be tricky to know what to look at and to know how to apply it. And then that's really, I think, one of the main benefits that we help people understand in the training. It's like, hey, we have a problem solving process. It's a methodology that has worked incredibly well for me over the years. There's a number of problems that I worked on, like at Netflix, for example, where it was like, without a strong problem-solving methodology and a knowledge of the tools to be able to answer questions like, what's happening at my disk level, what's happening in the file system level, without the ability to answer those questions, you end up making mistakes, and sometimes you end up trying the wrong, expensive way. Like, hey, let's just double a cluster, and it's like, well, actually, if you just like change read ahead, for example, like read ahead is like the worst default on modern hardware. It makes no sense to use what every Linux distribution ships as the default. But if you use that, and pretty much everyone does, if they don't know, like if they haven't heard me rant about it over the years, people will go ahead and use the default read ahead, and then all of a sudden you end up fully saturating your disk. You're trying to read a few bytes of data, and every read does a ton of I/O, and you're just like, why am I doing so much I/O on the disk, but like none on the network? And it's just a mess. So, being able to like figure that stuff out is super critical.
Yeah, absolutely. And to that point, Tom's just asked if he's gonna get banned for recommending Axon Ops. We use Axon Ops as part of the training. It's one way to get visibility into your cluster.
That was one of those things where it was like, develop it from like, should we build dashboards and like a whole monitoring stack as part of this training, or can I put all that time to better use somewhere else? I'm glad that we went with them. They've been an awesome partner for us. The tools have been great, and they have a much higher resolution than like everywhere else I've seen is like every 30 seconds you get metrics, and like things like the JMX exporter actually have a ton of overhead. I've seen.
Yeah, and doing it well is really hard.
Yeah, and there's a few percentage points overhead, maybe, depending on what you're looking at. But like, if you were to like look at the JMX, the JMX exporter, for example, like I've seen it take 30% CPU overhead when scraping. If you're scraping at a frequent interval. And then there's also DataSex's MCAC. The last time I used that was about 2 years ago, and I was seeing a 40% overhead from that. Like it was out of control. So monitoring shouldn't break your stuff.
Yeah,
basic, But when done wrong, it can, because there's a lot of metrics. Cassandra will kick out tens of thousands of metrics if you have a lot of tables. Let's keep going on these questions. I like how we're getting questions. I think we can kind of get sucked in. I can go a few more minutes. I can go a little bit longer. I had originally put this till 11:45, and if you have a little bit more time, you can.
I have until like 50. I've got to stop after that, but I think we can get through a couple more of these. Should we go to Gavin's question about the tokens?
Yeah.
Since we just.
Well, let's try and knock these out real quick. We got 10 minutes.
Yeah.
We're going to try and get all the questions.
I think num tokens. Yeah, we can talk about a bit. So there's actually a paper on this by my colleague Joey Lynch.
Let's state the question. Let's state the question first.
Oh, sorry. Go ahead.
Yeah. Can you please elaborate on the changes of 256 to 16 to 4 as the recommendation num tokens? Go ahead.
All right. So, a colleague of mine, Joey Lynch, and some other colleagues of his wrote a paper on this, and that's the best paper. I'll find a way to make that link available to folks, and if you want to take a read through it. But really quickly, in Cassandra, there are a whole bunch of operations that are order of number of tokens. So, if you have a 10 node cluster with 256 vnodes per node, and you have another one which only has 4, you're doing a significant amount more of operations on the cluster with the 256 vnodes. What operations? Repair is order of number of tokens because it does it per token range. Compaction can be affected by the number of tokens, and also any sort of scan to I scatter gather sort of query can be impacted by number of tokens. And so you'll start to see that the performance of these not only suffer because of those, and but also the performance of the cluster as a whole suffers because of those. So it's not just like the individualized repair. The benefit you get, right? Because the more tokens, ostensibly, the more availability, the more resilient to failure you are. But if you go take a look at Joey's paper, he's got some great numbers and graphs on this. There are like significant diminishing returns for the performance cost that you get from increasing the number. So 16 was the default that the community settled on, sort of balancing those. John and my belief is that 4 is the number that best balances availability with performance.
Yeah, I would never recommend anybody go over 4. There's just no reason for it. So I'll say real quick, one of the other things, the more tokens you have, so this is going to be kind of going to get ahead of myself a little bit. One of the other things that's negatively impacted is streaming. So when you have more tokens, more SS tables are going to be like, when you add a new node to the cluster, it acquires a number of tokens. Those tokens are going to land somewhere, in the ring. And if you look at the way an SS table is set up, when the token lands in the middle of those, one of the things that happens as a result is it makes that SS table now ineligible for 0 copy streaming, or just the optimized streaming path within that can send entire SS. So there's 2 streaming paths, or there's 3 streaming paths. I have my blog post next week is going to go into detail on this, but there's this old slow path where we literally go through and we read like row by row, and we're just like, here you go. That's pretty slow. There's and then there's a 0 copy streaming path, which is ridiculously fast, where we just copy entire SS tables directly to the network using the Linux kernel send file command. And then there's another internal one that actually reads the data through the JVM and encrypts it and sends it out. So those 2 last paths I talk about, super fast, and they're awesome. It's harder to use those when you have more tokens. And so it affects data density. It's actually one of the things that kills data density.
Well, that's a good transition to our next question, actually, which is Sarma's, and how to increase data density per node.
Yeah. So Sarma and Thomas, I'm glad you're asking. Thomas, I love how you're calling me out on my data density stuff, because I have been talking about 20 terabytes per node. In fact, I've been talking about 20 terabytes per node for 10 years. I've been saying for 10 years that this has to happen, or Cassandra will be obsolete. And I'm so glad that it's finally a reasonable thing to do, depending on your workload. I'm going to come out with, I keep talking about the blog posts that I'm working on, videos. So there's going to be a lot more content on this. I don't think I can get all of it crammed into the next 5 minutes, but you're effectively bottlenecked by streaming, repair, and obviously your individual node's query throughput. Streaming is, like I said, 0 copy streaming. Awesome. Helps out a lot. You can transfer an order of magnitude faster, so that helps when you bootstrap new nodes in. Repairing all that data, kind of a headache. Incremental repair helps out a lot there. Our patch should actually help out the repair performance in Cassandra 5, because it's going to make things a lot more friendly on the IO side. There's GC. It's kind of a lot. Compaction in general is actually, like, your compaction strategy is important. if you're using size-tiered compaction strategy, forget about it, because you won't be able to stream fast enough when new nodes join into the cluster. You have these huge SS tables, and they're going to like trickle their data out across your network.
Yeah.
No good.
And you have no bound on the SS tables, so you can end up with SS tables that are so large that you'll actually fail to stream them entirely.
Yeah, it's just terrible. So UCS is a huge improvement there.
Yeah, and actually, so Piotr just asked if there's an easy way to explain UCS. I think the short answer to that is no.
Yeah, it's a long one.
We could probably dedicate another like 20-minute segment just to UCS if folks are interested.
There's talks that have been given at Cassandra conferences on UCS. I'll probably do something on UCS as like a dedicated thing, but the high level of UCS is it can replace both leveled compaction strategy and size tier compaction strategy. You can make changes to the strategy without resulting in massive recompactions like what happened right now. And no matter what, you can put a fixed size limit on your SS tables because it uses data density as a signal. Like let's suppose we were to compare it to size tier, where size tier just groups things by size. UCS groups by density of the keys, and so it applies that same density to that metric to the levels that are in when it's in leveled mode or when it's in size tiered mode. Instead of looking at the size of the SS tables, it uses the density of the keys again. So it honestly, I don't know if people are aware of how big of a deal it is, but it is one of the most critical things to getting to 20 terabytes per node.
Yeah, so, I'm excited by how I haven't played with it very much yet, but I'm excited by how excited you are.
I'm like I actually have I have a customer that I mentioned they're pushing density. They want to go from 600 nodes. I said, hey, we can cut this in half. Right now we're doing 3 terabytes per node. I'm like, we can cut this in half, and then we'll cut it in half again. So once our patch lands, we're increasing density for them, and that means they're just going to use half the machines. Yeah. So we're going to literally throw away 300 machines.
Wow.
And that's huge
awesome.
savings in Amazon, right?
Yeah. Big deal, right?
Yeah,
I love one of the other things we talk about with the training and just in general is like performance is money.
Exactly. A lot of people think when I talk about performance, they think it's 1%. Like I actually have seen people be like, yeah, optimization. It's like people try to quote this premature optimization nonsense. I'm like, I regularly get 10x improvements.
Yeah.
So this isn't like some nonsensical thing. Like the things that we've worked on, together, the things that we've done in the training, the evaluations that we've done, the patch evaluation. This patch is a 10x improvement to compaction's efficiency. It's nuts.
Yeah, it's insane. So, should we get to our last question here from Sarma?
Yeah, Sarma. Last but not least, Sarma. Love you, buddy.
Yeah. So Sarma's last question is, what is the max RF you think is good enough for use in Cassandra?
It really kind of depends on how much you care about and how paranoid you are.
Durability, cost, all that. What I'll say is I never run more than 3 replicas a data center, and typically run in somewhere between 1 to 4 data centers, depending on the use case.
If you have multiple, and the key part of this is running multiple DCs. People might be like, oh, I'm going to run a lot more replicas. It's like, well, if you, that's okay. I can see that if you are running a single DC and you go, well, if I lose one node, then how do I, then I'm on the brink of disaster if I'm doing quorum. Okay, I get that, but if you've got multiple DCs, you just fail to the other DC. If you can't, if one DC can't serve traffic, you just fail over to the other one. That's one thing I think Netflix actually does phenomenally well, is that exercise, constantly being like, we just shut a DC off and nobody knows.
Yeah,
it's great.
Yeah, and that's again like the strength of Cassandra. So yeah, I would look more at and then you could argue your RF across 3 DCs with RF3 is 9, right? So, but it's better to put 9 in 3 data centers than 9 in 1, and also because assuming you're using the local quorums of the world for consistency, if you have 5 replicas, every request now gets more expensive than when you have 3. Exactly. The other thing I've seen and I see it mostly for cost, is RF2. So to kind of flip this question on the head for a moment, I'm not the hugest fan of RF2. You don't gain anything above using local 1 in terms of consistency at that point, because you have 2 replicas, so a quorum is both of them, so it's either all, or you say I don't want to do that and I want to do local 1. But you are storing a third of the data. So if like your disk costs or EBS, just because of the massive size, like I've seen that justified before, but it can lead to all sorts of like availability issues and things like that. So you have to be very, very sure that you're willing to take the risks to justify the cost savings for it. And, you know, I've seen some cases where that's impactful enough, but you really should be thinking about it.
Yeah, it's you know, it's interesting that you mentioned that, because this kind of also touches on the data density discussion. There's a paper that came out a while ago, and some code that's been added over the years, and I think it's going to get some improvements maybe in the next release, but I'm not sure. Transient replication and cheap quorums. The idea is if you've repaired your data, you don't necessarily need to hold on to as many copies of it. So you can actually, like, if you've got, let's say, RF3 and then you're completely repaired, the idea is you can throw away one of those copies, because you can actually achieve quorum by only querying. Like if you query the repaired data, you don't need you don't actually need it on all the nodes. You can just limit it to a subset of nodes, and it allows you to massively improve your cost profile. Because if you've got, let's say, your example, nine replicas, it's like, do we really need, like, if we can fail over to the other DC, do we really need every DC to have a perfect fit? Like, we don't. So,
that's based off a concept called witness replicas.
Exactly. By the way. Yeah. Thomas, you asked a question. Fewer machines that are bigger in size. So, depending on the case, it could be that. However, what we have found, like, if let's suppose that you use Cassandra, which I'm using now for this cluster. If you're using Cassandra, then you are most likely going to be using EBS. When you're using EBS, it will be, I can almost guarantee, unless you're using like T micro instances or something, the bottleneck that you're going to hit is going to be on EBS, because of the way compaction is implemented today. And that is actually the reason why our patch is such a big deal, is because that 10x improvement in compaction efficiency, like, you can, again, I don't want to keep hyping this thing up, because to me it's like, I'm just like so excited. When we looked at the numbers, we were like, oh, we have a 3x improvement in compaction throughput, and we're using like a third of the IOPS. So when you're using EBS, you're limited to 16,000 IOPS. Every time you do a read, it counts as 1, and that's up to 256K. But compaction is literally reading one compressed chunk at a time, which might be 4K, 8K.
4K. Yeah, if you're following other advice we give, they're very small, right? So
exactly. So now you're just destroying your IOPS quota through compaction, and that actually becomes your major limitation in performance, because if you can't compact fast enough, then you have to use more nodes, but you're really just paying for like these disks, and they can't keep up. So our patch massively improves that, and as a result, you can pack more data onto each node without changing the instance size. So once we have this stuff merged in, we'll be doing more videos, we'll be doing more follow-ups. You could cut the cost of your cluster in half if you run on EBS with Cassandra 5 after we merge this patch in. And I'm so excited about this. Like, if you're running 1, 2, 3 terabytes per node right now, you can get to 10 on EBS. I've done it using builds that we have, like, you know, your GitHub branch. In testing of that, it works. So I love it. And there's been a lot of other people that have looked at that. We've got multiple people that have contributed on the review. We have several people that have reviewed it. Community is really excited about this. Cassandra 5.
Yeah, and I mean, to Thomas's comment, we had to double check. Like, we've run these benchmarks so much now because the numbers were so just outlandishly awesome, and we've had other people run it as well.
Yeah, it was. So Thomas, to your if you're curious about it, go to Cassandra Jira, Cassandra 15452. It is probably one of the most in-depth performance analysis that's ever been done on like an optimization.
Very, very proud of the work.
There's very, very few cases where especially because our goal was to bring it into 5.0. We already released, right? So this is coming out in a patch release. So we were super thorough, and don't forget, there's also people who are running this in production already. Even on local SSDs, they get a 15% improvement in compaction throughput. EBS is going to be I think, like I mentioned, it was like 3x, and that's with any configuration. You can do it the minimum number of IOPS, which I think is 3,000, or you can go up to 16,000. Across the board, we always see an improvement because we can always saturate IOPS on the disk.
Yeah, and just to be clear, we're not talking about like the special IO Express kind of stuff. We're talking about the GP3, the general purpose EBS here. Those
other instance sizes are those other disk types are awesome, but they are crazy expensive. And again, like, I'm looking at my customer and they're like, we got 600 nodes. Like, we literally, it makes it prohibitively expensive.
It's wild.
Yeah. So this is like a multi-million-dollar savings for like one team. I accidentally, it's kind of funny. I know it's expensive because I accidentally left one of my test clusters up for like a few days, forgot about it, and I have $1,000 AWS bill. Like, great.
Yeah.
So I kind of screwed myself there. Idiot.
Yeah. You gotta set up those billing alerts. But speaking of that, hey, I'm gonna have to get running here. As much as I could talk about Cassandra all afternoon.
Yeah.
But thank you all for joining us and for the questions. It really helped make this like a discussion, and really appreciate it. And I think John and I will be trying to do some more of these in the future.
Yeah, we're definitely gonna. I think we'll get a couple scheduled, and there's gonna be blog posts and stuff coming out, and in this patch. So we'll be talking more about 15452. We're gonna be talking more about training. Folks are interested in the training, go to rustyrazorblade.com/training. It starts at the end of April. Like I said, there's about 6 slots left. I guarantee you will walk out of this knowing way more. So if you don't feel like, if you're like, hey, I don't want to spend money on this myself, get your company to pay for it. Come on in. You'll save, you will save money. If you have a cluster of any size at all, you will save way more money than the cost of the training. So that's my guarantee.
Yep.
Yeah.
Yeah.
All
right.
Yeah. So thanks everyone for joining. Really appreciate it. I had a great time. We'll do more soon. And thanks, Jordan. I had a great time, bud.
Yeah. Thanks for including me, man.
Great time. Thanks. Endorsement on the training from Sarma.
Yeah. Sarma has joined, and yes.
Sarma says this training is amazing. I attended the first batch. It's true. He was the first one. Actually, Sarma, I think you're the first one to register.
Sign up, yeah.
Yeah, we should send him a trophy.
Yeah, Sarma, thank you as always for your support and for your questions. And thank you all who participated today. Piotr, Thomas, Prabhu, Gavin, and Juraj. We appreciate all the questions. It makes these conversations better for the community.
100%.
All right.
Alrighty, we're done. We're shut it off.
All right, we did it live.
All right, bye folks.